Hey guys, this is Mainak and you're watching Civil Bros. So today I'm going to design a building in Etabs. So for starting, you don't need any experience. If you follow, you can just design it along with me. So let's start. So we'll be designing this particular building, and I already have the structural drawing, and I'm going to use it to design this particular building. So let's get started. So first of all, when you open Etabs, you go File and click on New Model. And if you are watching this video for the first time, and to appreciate the effort, make sure you like the video. Okay, so display units you select as per your country, and we're going in Indian, so all the Indian steel code, Indian concrete code you select, and then click on OK. You have to only do it once, you don't have to do it multiple times. Now there are a couple of ways in which you can import the grids. In this video we're going to just go to default method here. So let's see, this is the grids. Okay, these are the grids. So we have the grids in the X direction. So in Etabs, this A, B, C, D, E, F, G, this is X, and 1, 2, 3, 4, this is Y. So in the X direction we have 7 number of grids in total. So we'll just do here 7. Just click here and 7, and in the Y we have total 8 grids here in the Y direction. So we'll do 8, and spacing we'll just do custom grid spacing here, and can edit the data here, display grid as spacing, and okay, I think we haven't changed that. Okay, so let's do that. It was 7 and it was okay 7 and 8, and then we have this edit grid data, display grid as spacing. Okay, so let's start here. This default spacing here for the first one, we'll just copy. Already the spacing is there, 4.606, so we'll write all these spacings here like this, 4.606, and then the next one, it is, let's see, it is a 3.328, and then we have the next one is 2.461, and the next one, let's see, 2.179, and then we have here 3.996, and then we have 4.394, and then we have this here. And in this Y direction, let's see the spacing. You have to do it from the bottom. In the Y direction, 2.365, okay, 2.365, and then we have 2.266, and then the next one is 2.805, and then we have next one is 2.169, and then the next one is 2.104, and then you have the next one is 1.707, and then we have next one we are having is 3.484, and then click on OK. Grid spacing is done, and now we have the number of stories. It's G+2, so total there is 3 stories, and including the bottom story for the foundation height, it will be 4 number of stories. So it is okay. Typical story height is 11 feet 3.35 meters. Bottom story height is, you can see, bottom story height is the, I'll explain, it is the plinth height plus the plus the foundation level height. So it is 1 meter, there is a plinth height, and foundation height depth is 1.5, so total 2.5 meter for the bottommost story here, 2.25 meter, and then we are going to click on OK. So by default this window will open, and we already have the grids, and you can match the grids in just opening the diagram. here, you can match the grids 4.606, 3.484. You can see 4.606, 3.484 perfectly arranged in the grids. Okay, so now we're going to do some things. We're going to click on, first of all, we're going to click on define and material properties. Material properties, so we have to check which one is of concrete. Double click and you can check this is steel for the structural steel, and this is the concrete. Okay, so for this one we'll just add copy of material, and we will do here M25, which will be the grade of concrete which will be used here, material type concrete, and this one density just 225. Okay, and then we can click on OK, and then we'll check which one is for reinforcement. This is the rebar. Okay, so we'll add copy of material, and it will be FE 550 and rebar, and we'll just change the material properties. You can just see from the internet, change all of them, but I'm just going to change one. You can change all of them. FE 550 rebar which has been used. Click on OK, and we are done here for the rebar and the concrete. Now the next definition will be the section properties. So let's define the beam and columns. So I already have designed it in Strat and RCC, so I already have the properties, so I'm going to use the same properties in here. If you see for the columns, we have two types of columns here, that is 500 to 500 and 550 to 550. So we'll define both. So we'll see which one is for the column here, concrete column. I think this one. So double click and see, check. You can check, this is the concrete column. So we're going to just add a copy of this property. Okay, and we'll go see for the column 500 cross 500 is the name of this, and we'll just select our property for concrete M25 grade and change the size here 500, and reinforcement will change the reinforcement F550. Column design is selected, and you can change this cover at 20 and we are good, I think. Okay, and then click on OK, and then click on OK, and then select this, and then add copy of this material property, and this will be C 550 cross 550. So this is the second property. I'll just give the spacing to, and this we don't have to change because we copied it. Okay, and click on OK. So these two are done for the columns. And for the beams, we have two types of beams here. If you see in the plinth layout, 250 to 350, and another we have 300 into 450. So two types of beams are there here, and we are just going to, I'm just open the topmost floor. You can see two sizes are there in fact for the beams. So let's provide the same size, and here let's see concrete beam, and we'll just add copy of property, and this B 250 cross 350, and then it is and we'll just M25 grade of concrete, and width is 250, and then it is 350. Modify rebar, it is for the beam, and just select the property here, and cover 30 mm cover will give. Okay, click on OK, and click on OK. So I'm just confused, did I give or did I not give? I'll just see whether I had, okay, I hadn't changed that. Okay, 550, I should have changed that earlier, I forgot, so I'll just do it now. Okay, so concrete beam B2 to 350, and we'll just copy property, this one, and this will be B 300 into 450. Okay, and then 300 and into 450. Rebar I don't have to change because already did in the previous one. So two beams, two columns, and I'm good. And I'll define the next thing is the material section properties for slab sections, and this is slab 1. I'll just copy a property, and my concrete is there, slab 150 mm, and just change this 150 and click on OK. Okay, and then click on OK and define. And then what next we have slabs properties, reinforced beam bar sizes you can change, not required. So define diaphragms, so we can define the diaphragms here. Just add new diaphragm. Okay, D2. I'm going to do it for all the floors individually, and D4. So this is G+2 building, and including headroom, I think there will be 4. So let's click on OK. Semi-rigid you need to take if there are more amount of in-plane forces. You need to take semi-rigid. Otherwise you can go with rigid. So I'm going to go with the default rigid version of this thing. Okay. So once we have defined all this, we can go and go to the next case, which is the loading part. Okay, so before just going to the loading part, go to define and going to this load patterns. So we have the self weight multiplier in the dead load part. Okay, the self weight multiplier in the dead load part is there, and live load part is already there, and I am going to add another one in which there will be no self weight multiplier, and because I'll add the other dead load. Okay, so all the other dead loads I'll add in which there will be no self weight multiplier, like the floor finish load, the wall loads. Okay, and these all these loads I'll add in the other load without the self weight multiplier other. So I'm going to just call it other dead and click no. Okay, now I go to define again and define load patterns once again. Okay, I just need other dead and self weight multiplier 0 and add new load. Okay, in this I'll put all the loads. Okay, and then we'll go SL X direction, seismic load in X direction. I'm designing the building in zone 5, earthquake zone 5, so it is seismic, and self weight multiplier 0 obviously, and you can see you have to select the latest code which is available to you. Actually it is 1893-2016. I can select this from here. Okay, so here we have up to 2015, but latest one is 2016. If you use the latest version, you can find that. Okay, just click this and add new load, and the same thing in the Y direction, add new load. Okay, so seismic load, you just going to click on modify, and this is X, so just all the Y elements are gone. Bottom story always take for the plinth level, which is base 1, and response reduction factor is 5 for zone 5 building, and as per code for zone 5 the Z is 0.36. I think I should show you these things. So you can see here for just let me just so you can see response reduction factor for RC buildings, special moment resisting frame, which is our, and because we are considering ductile designing, our response this is 5. Okay, and what else do you have? And Z. Okay, Z also, let me search in the code, I'll show you. Here in this table, in this next one, you can find for all the seismic zone 5, the response this Z value is a 0.36 for seismic zone 5. So for all the zones you can find the, and then you have the importance factor. Okay, so importance factor is also in the table here. Let me show you. So in the latest code we have 3 types of importance factor: 1.5, 1.2 and 1. One is basically for normal buildings. If you 200 more capacity, then it is 1.2, like in apartments, and for important buildings like hospitals, bus stations, public buildings, basically, which is 1.5. So we're going to take 1 here, and then this is the time period, approximately it is this, and then we user defined. Obviously we're going to go with user defined. So we have this clause and 7.6.2 where you can calculate this. So depending on the height of the building, you can just edit this. So basically the height of the building here, which we are having, is 3.35 into 3. So this basically 10.05. Height of the building is 10.05, and you have this dx and dy. So this is distance in x direction, distance in y direction. You can just calculate this. So in x direction, the distance is the total distance. You just find out it is 20.963. Okay, it is 20.963. Sorry, 0.963, and this in the y direction. Let's see, then we can calculate this. In the y direction it is let's see from the plan, turn on the ortho, take the dimension here, and so it is 16.899. okay, in this direction 16 point, let's take 16.9 minute. So and then t is equals to 0.009 h by root over d. So this will be different in different directions. So we are now going for the x direction, it will 0.09 into 21.176 divided by root over of dx, that is 20.9, and it will be, the value is coming 4.42 approximately. So we'll just go with 0.42. You can see 0.42, and if you go it's user defined, then it's this program, I know this. So 0.42, and then we'll just click on OK. And then similarly for this one, modify lateral load, y direction obviously will be there, and then this is the same, then we go with base story 1, and then this one will be calculated here. Only the dy will change, and instead of 20.9 I'm just replacing it with 16.9 in the calculator, and it is 0.463. so I'll take 0.46, and 0.46 is being taken. Click on OK, and then click on OK. So the loading has been defined, load cases, and then we have the load combination, define load combination, add default design combos, concrete frame design. Okay, we're just going to go to concrete frame design, and then click on, can convert this into editable also. Okay, and then click on OK, and then just click on OK. Design combination is done, and then we are going to define the mass source. So what is the mass source in StatPro? In the earthquake loading, we just define the mass source here in the definitions part. So this is the same thing. Those who are transitioning from StatPro to Etabs, for them it will be easier, so that's why I'm telling. So I'll modify this. Okay, and element self mass, I'll just untick this because I'm already going to take the dead load into consideration. Specified load patterns, okay, dead, and click on add, and other dead also I'll take. Multiplier is it is 1 only, and then click on add, and then for the live load the multiplier will be as per the code. So we'll just show you the multiplier. Yeah, this one, table number 10, up to 3 the live load is 0.25, and above 3 it is 0.5. we taken this in StatPro as well. So we're going to taking live load of 2, so it will be 0.25 here. So live load multiplier 0.25, and click on add. So all the live load multipliers are added, and then you can just click on OK. So default mass source is this one, and we already defined it. So mass source has been defined, and the diaphragm has been defined, columns have been defined, and then our everything has been done. Now we can just go for the modeling part. We'll assign these supports later because of a reason I'll just tell you later. So we'll just go in the story. This is the story, base story, and the plinth level. So let's go in the plinth level in this particular diagram, and then we'll take from the left side the best way to assign a column. So it is the quick draw column option. I'll take this, and then I'll select the column property. First of all, I'll select the property of 500 into 500 for now, and then I'll just assign the columns where there is. In the previous output I got 500, but you can check any size and then check. So you can do it. So in this particular thing, line 1, these two are 500, so we'll just simply can assign this like this, and the second one is actually 500, right? And then we have these three as 500, and I think the bottom one also, yeah, bottom this also 500, and the shape of the building is like this, and this one is also 500 here, and we actually didn't have any column here, but I'm going to assign one column here as well. Okay, and in this row, the middle one, this one also. So I'm just assigning as per this diagram. Okay, okay, and then the remaining columns I'll just assign it as the second option here, 515 to 550. I'll just assign it here like this. Okay. So now let's assign the beams here. So for the beams, I'm going to just go with 210 to 350 for, since all of them are primary beams, so no worries. So we can just assign the beams here. So for assigning the beams, quick draw beams, beam columns, you can select draw the beams like this. Okay, just take this property and we can just select them like this, or we can just draw them like this as well. This one, and then this one, make sure you don't have any overlaps, something. So we can just see the extruded view also. So all these things are done. So now these, we don't have any columns here, so we'll delete them. Okay, so columns and beams in this particular level is been done. Now I want to copy this to the next level. Okay, so I'm going to just use this option of select and select by object type, beams and columns, select them and close, and I'm just click on the 3D view. So clicking on the 3D view is important for a reason. I'll just show you. Edit, and then we'll use the option of replicate, story wise replication, and story 2, 3, 4. Since I'm only in story 1, I'm just hover over apply, not click it. You can see in the 3D view the effect which it will make. Okay, then click on apply and then click on OK. And in the 3D view, we can turn on the extruded view to check whether it has been done. Now just right click and add, modify this story data, modify story data. You see master story, this is actually used for copying, and the similar to if you make this similar to a particular story, then all will be everything will be the same. So I'm just making story 2 as my master story, and this will be similar to story 2, and this is no. Okay, this is similar to master story, and these two story will be same, and this one will be different, right? This is the terrace level, and I'll add and the story with it. Okay, add story and keep existing story height, replicate no, not no replication, and this is the headroom. Actually story height will be 2.8 meters, and then click on add, and then click on OK and close this. So Now once this is done, now we can just go to the base and select all the points here, and we'll go to assign, joint, restraints, select the fixed support, apply and OK. So if you want to see whether the fixed support has been assigned or not, just go here in 3D view and click on new window, and this particular view, select this and click on elevation, select any point of the elevation, apply and OK, and you can see the support as the fixed support symbol has been assigned. Okay, so once this has been done, now we'll assign the slabs and assign the diaphragms as well along with the slab. So let's go. Now this next view is the plinth level, no slab here. Okay, so next level is the first floor slab or the ground floor slab or the first floor. Here we're going to assign the slabs here. So, and before assigning the slabs also we have the cantilever projection, so we're going to do the cantilever projection here. Okay, so we're going to select this. So you don't need to press Ctrl while selecting this, like in Stat 2 you need to press Ctrl. So it's similar to AutoCAD, where for selecting multiple objects you don't have to press Ctrl. Selected this, edit and click on replicate. This linear in the x direction, it will be in the left side, so it will be minus 1.7 is the distance, and click on OK. And then we are just going to use this. So first of all, just click on this one, this option, draw beam column, and this one property, we'll just go with 15350, and I'm just going to click on the center and then joint. Similarly, escape, once again click on center and joint. So like this we're going to just do the entire thing. Similarly, we will add another one in the front. So select these two columns and then go to edit and then click on replicate, and then in the same thing it will be in the y direction because it is in the bottom, and click on apply, OK, and take this, and then this time I'm just going to go with the second property, that is 300 to 450, and add this. Now for all the roof beams here, just select all the vertical span members here like this. And right click, and then the properties is 300 into 450. And this one is 250 into 350. Okay, so this is okay for now. And now we need to apply the slab. So for applying the slab, you have this option of let's use the option of quick draw one first, quick draw floor slab, and we are taking this slab 150 mm, and we are applying slab everywhere except the case where we have the staircase, right? So we have a staircase in this portion, right? So we're just going to avoid this portion and this portion, and then for the remaining part, the cantilever part, you have to use the draw floor option. Slab 150 mm selected, one first point, second point, third point, fourth point, and fifth point. Similarly, 1, 2, 3, 4, 5. Done. Click on escape, and then what we are going to do, you can see here in the 3D view, in the extruded view, you can see if you rotate with the help of the mouse. So I'm going to select the slab. Okay, let's select the beam first, this particular beam, and this particular beam along with the slab we have selected, and I have selected 3D view is selected, and go to edit and go to replicate story 2. Sorry, the story 2 is this story 3, story 4. Let's hover over to apply. You can see the changes in the 3D view, so this will do it. So apply and OK. So the slab has been applied, and now along with this, now we're going to select this these slabs and copy them to all the floors. So select this, and I'm going to just let's select them all one by one. Except the cantilever, select all these slabs here. Okay, I think everything has been selected, and then we're just going to go to edit, replicate story 3 and story 4. Apply. Okay. Now I'm just going to go to story 4. In story 4, just there will be slabs here as well, because there is no staircase here. This is the story 4, and from the story 4 I'll just take this normal cursor and I'm just going to select this points, and then go to edit, replicate. This is for the staircase headroom in story 5. Just hover about to apply, and see the change here, and click on OK. Now we're going to go to story 5, and in the story 5 let's apply the slab. So just quick draw floor wall slab and apply the slab for the headroom. So now we can see that the modeling part here is complete. Right now let's assign the diaphragm. So let's start from the bottommost part, bottommost floor where you have slabs, this one. So just select this like this with the help of your mouse, assign joint diaphragms D1, apply. Okay. So let's go to the next one, select everything like this, assign joint, and then diaphragms D2, apply. OK. Go to the next floor, select this like this, assign joint diaphragms D3, apply. OK. Go to the next floor, assign joint diaphragms D4, apply, and OK. Now you're going to check whether everything is correct or not. For that, go to 3D view, and just can click on analyze and check model, select all, click on OK, and it will take some time, and you can see whether all the steps you've done has been checked. Model has been checked, no warning. So we have done everything correctly, there is no warning. Okay, you can now close it. So now let's assign the loads one by one. So let's just go to the plinth level. Okay, so I'm just going to select all the beams in the plinth level here like this. We can also select this in the elevation, I think, so it will be easier. So beams in the plinth level, beams in the this one, except the parapet, this one I'll apply parapet wall load, and this one, right? So all these beams here, I'm just going to assign the 10-inch wall loads here. Some will be 10 inch, some will be 5 inch, but I'm going to assign the 10-inch wall load here, which is 14. And the load calculation, if you want, I can show you, but I'm just assigning it now. So I'll assign here frame loads. So we'll just go over to frame loads, and this will be distributed, right? And then it will come under other dead because there is no factor of this thing. Point of application gravity, and the load is 14. Okay, so this is the gravity. In StatPro we had minus, but since this is gravity, we don't have to just click on minus. Okay, and click on apply and click on OK. So this has been applied here. And for the cantilever beams, just select the cantilever beams like this. Okay, just click on escape and then select the cantilever portions here, like this, and like this, right? And let's also see, we'll just see the effect here. The beams which are selected, see them here as well. And let's, okay, first of all let me just select member, select by object type, and slabs, right? Close, select, close, then you can go to view and make selected objects invisible, just for having some clarity. Okay, so then we can just actually let's select them in all the floors individually. So let's go into the for applying parapet wall load, let's go in the topmost floor, which is this one, right? This is the portion where we have the parapet wall, and this portion, and this portion, and this one, and this one, and this one, right? And then in the bottom floor, let's select this portion, this portion, this portion, this, and this. Bottom 1, 2, 3, 4, 5, and 6. Bottom 1, this is done. So we'll just go assign frame load, distributed, and parapet wall 3, gravity, and other dead, and click on apply and click on OK. So this has been assigned. If you want to see this, just I can just go to this option, display frame load assign, select the load type of load, and click on apply. Select this window. So this is showing this right here, this 3, and then we need to apply one other load. Okay, so let's go to the topmost floor, this one, and not this one, the bottom one, below this. So in this portion we have the 1, 2, 3, and 4. We have the staircase, so there will be 10-inch wall load. So assign joint frame loads, distributed 14 in here, apply and OK. So now this has been applied, and after that, if you want to apply the remaining load, that is a floor finish load, we have to select the slabs. So I have to make the slab visible, but here I already have the slabs visible. I just select the 3D view and turn off the extruded view and select the slab, right click, just go to select by object type and floors and select. So all the floors have been selected. So I'll just assign shell loads, uniform loads, assign shell loads uniform, and then this is going to go under other date, and this is 0.5 for the floor finish load. Okay, and click on, in this add to existing loads, click on apply and click on OK. And then you just go again, select object type, floors, this time we'll assign the live load. So assign shell loads uniform live of 2. Click on apply, click on OK. So dead load and live load have been applied. Earthquake load, it will take automatically. Load combinations have been applied. Okay, so again we are going to go to analyze, check model, all is selected, click on OK. If there is any error, it will show model has been checked and there is no error. So now go to analyze and set load cases to run. So you can see these load cases are selected and action this is run, and then you can just click on run now. You save the model here. Okay, and then the program will run. So I'm just going to close this just to improve the view. So this can see this is the deformed shape here, and analysis has been run. So let me just close this one as well. Let's only keep the 3D view, and if you just click here, you can show deformed shape. And okay, so this one is the show deformed shape, and this is display frame reactions and all. So we'll check everything. Let's start. So we'll go to display, and we are going to go to our see the story response plots. Okay, and in the story response plots, you see, okay, story response plots, we are going to display type maximum story displacement. We're going to see, and we're going to see the earthquake load X, SLX. You can see the maximum displacement is your around 7.2 mm. So now we are going to check this, and as per our IS code. So 7.1.1.1 clause states the story depth in any story shall not exceed 0.004 times the story height under the action of design based shear VV and partial defective factor taken as 1. G+2 building story height is 10.05, okay, into on the 0.004. It is so it shall not exceed story drift in any case shall not exceed your 0.04. So this value is in meter. This 10.05 is in meter, so this value is in meter. If it's in mm, then it will be 40.2 mm, and you can see the maximum displacement. If you take this is around 7.2, so this is we are all right in this. So we can change this to seismic load Y, and in Y also the value is in range, and we can change this particular thing as from maximum story displacement to maximum story drift data, and we can check this also drift it is unitless, okay, and drift data also we can check here for the SLY and SLX we can check here. So this is actually a ratio here of the story drift or story drift displacement, which you can check here. The next check which you can do is the model response spectrum. Just going to close this and going to go to display and going to click on show tables, okay, and analysis results, go to results, go to model results, and then so just click on model participating mass ratios from here and click on OK, and we have the table here. So just close this and just open this, okay. So this is the table which you can see. So these are the 12 number of modes, and you can see these are the time periods, and you can see the values. So as per the clause 7.7.5.2, number of modes to be considered, the number of modes nm to be used in analysis for earthquake shaking along is considered, and the considered direction should be such that sum total of modal masses of these modes is considered at least 90% of the total seismic mass. So at least 90%. So you already have 90% here, okay. It is 0.9 some. So for the last, so we are satisfying this criteria for this model mass. So you can have any other checks I'll discuss further. For you can see this is the effect of the model mass participating factors, which you can check here. You can also check the time period, but for now let's go to concrete design. So for the concrete design here, and you can just do the concrete frame analysis here, and after that we can check the results here. So we're doing the concrete design. So you can see the reinforcements have been mentioned here. You can also open it in the elevation view. Let's open the elevation view. It will be a little bit easier to just visualize. Let's go with one. Okay, you can see the elevation view of the reinforcements which are available here, and this one, and you have you can have the option of checking whether all members have been passed or not. Okay, verify all members passed. So all members have passed the design check. So like this you can see, and now then you can just go to view and revise preferences. If you want to change any preferences, if you suppose you want to this P delta analysis done, you can just click on yes, and then you can just change it and the results will change. Okay, so you can do that. So you can just check any select any member like this and right click on this, and you can see the reinforcement will be shown in detail. And if you want the summary will also be shown. You can see the section type, properties, and the required AST will be shown. You will not get the just diameter of the rebar, but you will get the AST, from which you can calculate the number of rebars. So this is all which is there in the concrete design part. And if you want to design the foundation, you will need unfactored load combination. So I am just showing an example for that. Okay, so let's go to define and go to load combinations. So you can see all this load combination have like modify. I'll just click on modify, has these factors. So all this load combinations, we need to add copy of this combos. Okay, and suppose let's take this at copy of this particular combo, this dead load, live load. I'll just take more load at copy of this combo. So just go and just take unfactored number 1. So like this we will do unfactored number 1, unfactored number 2, and this scale factor, we'll just do it this is 1, and click on add. Sorry, not click on add, just click on OK, and delete this and click on OK. So unfactored 1 and click on OK, and then we're just going to analyze. Just going to click on this, concrete design will be done, and after that we'll just go to the plan view, to the base view, click on apply and click on OK. Now we're going to click on display, show tables, reactions, base reactions. Okay, and you can see the base reaction for the unfactored one. This we are taking the Z, that is in the Z direction, FZ, and we are taking MX and MY. So taking these two values. Okay, and then in the gravity direction we are taking, so one force and two moments we can get from here. Or else there is another option, let's display support reactions, and the combination will just select from the combo, and unfactored 1 and FZ and MX and MZ. Just click on apply and then click on OK. So like this also we can see. So there are various ways in which we can do this, but this is it, and we'll be back with another video for the further. Just in the meantime, keep learning. Bye bye.